Hey everyone, and welcome to lesson 1.3, where we are going to learn how to solve some quadratic equations using square roots. And we should have seen an example of this at least once with our radical lesson, but we're going to take a look at a few different kind of cases of it here. So essentially, here's the warm up. Try to tackle those three warm up problems ideally before this video, but that's totally fine. This should be a good way of kind of checking your work. And then we're going to hop right into these solving quadratics using square roots. And really, given the skills that we have, we're a little bit limited in what we can do right now. So we're going to go over just like these two different special cases that we are capable of solving. So the first looks like a pretty traditional equation. The only difference being that kind of at the tail end of it, I'm going to have to deal with this x squared. But the first thing that I want to do is almost ignore it. So pretend like this is just a normal equation. So I'm going to add 2 to both sides, and I'm left with 2x squared equals 8 because those are going to cancel out. Again, I'm basically just pretending I'm trying to get x by itself, but really we have x squared. So then I get here. And once here, some folks are going to know what this number is, but they might not know the solving step to take. So if we kind of see what we've done, our first few steps, we added 2 because we saw subtract 2. We divided by 2 because we were multiplying by 2. And in this case, when we encounter a square root, x squared, we want to undo this by taking the square root of both sides. Okay, I don't want us just thinking about, what number times itself is going to give me 4. What we really want to do is probably just get to the point of being able to use a calculator and understanding that square root of 4 is just going to generate a number for us. We don't have to think too hard about it. One thing I will say is that your calculator, if you're taking a square root, is always just going to spit out the positive answer. But we know that -2 times -2 is also going to give us 4. So this is important that we put plus or minus 2. If we are just taking a square root and it's not in the context of like a real world situation, we need to make sure basically that our readers know that, hey, when I take the square root of 4, it could be positive 2 or negative 2. Those are both quote unquote solutions to this problem. And we're going to see kind of why that happens in just a second. So in our other case here, this equation on the right-hand side, it looks a little bit different because x itself isn't being squared. So our strategy is going to change just slightly. And what I'm going to say is we're going to try to get this term by itself first, okay? So anything that's being squared I want on one side, and anything not being squared I want on the other. So I'm going to accomplish that by adding 3 to both sides. So now I have x plus 3 squared equals 9. And at this point, everything on the left is being squared, so I'm okay to now take my square root of both sides. And we did that same thing on the left. We were able to get all the way just down to x squared being the only thing, which was nice. But in this newer problem, x plus 3 is being squared. So I need to wait until this step, and then I'm going to take the square root of both sides. Okay, and on this side, I'm just going to get x plus 3. And on this right-hand side, I end up with plus or minus 3. That's after I take that square root. Okay, and essentially I've got two different problems that I still need to solve because I generated two different answers when I did that square root of 9. I have plus 3 and minus 3. So what I'm going to do at this point, and this line's a little bit large for what I want to accomplish, is to basically show this as splitting into two different equations. So I have, okay, well I need to figure out when does x plus 3 equal 3, and when does x plus 3 equal negative 3? Okay, so I'm keeping the equation, but because I have that plus or minus 3, I switch it into two separate equations, and then I'm just going to solve them traditionally as I would. So I'm going to get x equals 0 from this, minus 3, minus 3. If I'm being careful with my signs, I get negative 6 here. Okay, so the answer to this is 0 and negative 6. So the answers to the one on the left were positive 2 and negative 2, and then the answers here are 0 and negative 6. And it's a pretty common occurrence that we're going to find two solutions to quadratic equations. We'll talk about, the number of possible solutions at some point. Might not warrant going over fully today, but we'll see that kind of fold out before our eyes. Here, I said that we could solve equations graphically, and this is basically our equation 2x squared minus 2 equals 6 that we had solved above. Okay, so 2x squared minus 2 equals 6. These are those graphs, and I did this so that we could kind of understand why we're getting plus or minus 2. Okay, so here, those two lines, the parabola and the line itself are crossing at two different points. That's why we're generating two solutions, because that graph is going to equal 6 at negative 2, but it's also going to equal 6 at 2. Okay, so this is just a visual idea as to, why we're not going to panic when we get two solutions, because in a lot of cases when I have this curved shape, it can hit that line multiple times. All right, so let's do a few more examples like this. And then I did include some steps for folks that enjoy steps. So we're isolating the squared portion of the expression. Then we're going to take the square root of both sides and solve the remaining equations. I'm going to do this one on the left. And this is what I'm trying to get by itself for right now. Okay, that 5x minus 10 squared. That is my squared portion. So I still have this plus 14 I need to deal with, and then I've got this like multiply by 2 out there as well. So I'm just going to subtract 14 from both sides. And now I have 2, 5x minus 10 squared equals 50. Going to divide by 2 on both sides. And now I've basically accomplished step one, right? I've isolated the part that's being squared. Now I'm going to take the square root of both sides. So I have 5x minus 10 on this side. It's no longer being squared because I square rooted. And on this side, I'm going to get plus or minus 5. Because I don't have x isolated by itself yet, this is the case where I need to consider, okay, I now have two equations that I need to solve. When does 5x minus 10 equal 5? And when does 5x minus 10 equal negative 5? And I'm going to solve these real quick. So this is now 5x equals 15. Dividing both sides by 5, I get x equals 3 as one of my solutions to that quadratic. Adding 10 to both sides, 5x equals 5. Divide by 5 on both sides, x equals 1. So in order to make, if we go back up to our problem, in order to make that left-hand side equal to the right-hand side, or equal to 64, x has to either be 3 or 1. Okay. Here I am on my second problem, and isolate the squared expression. So I have two different squared expressions here. So similar to like isolating x before, I'm going to try to get all of these on one side first. So I'm going to start that with subtracting 2x squared from both sides. And then this is 15. So I'm subtracting 15 from both sides. I still don't have my squared expression by itself. So don't think that 3x squared is the squared expression isolated. That 3 isn't being squared, so I need to kind of keep going one more step here. Now that I have it, isolated, I can take the square root of both sides, and I need to remember that I need plus or minus on my right-hand side. So this I'm completed with. I don't need to split this into two separate things really, because x is already by itself. If I wanted to be formal, you could say, oh, that means x equals 4 and x equals negative 4. Generally, we would just write that as x equals plus or minus 4. So these are some nice cases where kind of the square root works out to be even. I'm going to kind of meander through these examples where we might get something that isn't a perfect square root. Okay, so isolating my squared expression, then I'm going to divide both sides by 3 here. And here I need to take the square root of both sides. So square root, I get x plus 7 equals the square root of 8. I can simplify this right-hand side if I want to right now, and that's kind of going to help me out. So let's say square root of 8 could also be seen as, and I'll do this as like a little intermediate step, square root of 4 times square root of 2. So that's the same thing as 2 root 2. I think I switched colors, but that's okay. All right. I can, if I consider that positive or negative, I can split this in half. And if you want to like go to decimals at this point, you can also do that. I'm totally okay with that. This is going to be negative 2 root 2. Subtracting 7 from both sides. And here, this is where decimals can potentially come in handy because these don't combine. So they would kind of need to be left as two separate things. This side was negative over here. So yeah, if you have a calculator, you can turn those into decimals. It'd be 2 root 2 minus 7 for one solution, and then the solution on the right is negative 2 root 2 minus 7. Okay, let's do one more example, and then we'll see if we can practice this same thing. And this is an interesting case because it looks like the one where I'm going to isolate this entire parenthesis, but in fact, we'll find out that it's even a little bit easier than that. So I'm going to divide both sides by negative 2, which is going to get rid of that. So then I have x squared plus 7 equals 25 on my right-hand side. And I can keep going because this 7 isn't being squared. So if I subtract 7 from both sides, then I'm here. I can square root both sides. This side on the right, I might just call basically square root of 9 times the square root of 2. And I'm going to do that so that, oh, that's just a 2 in there. I'm going to do that square root of 9 because I know what that is. It's just going to give me 3. So that's where the simplifying radicals can kind of show up in these. All right. So there are a number of problems that I want us to practice and get exposure to. And I might even kind of whip through these and just have the answers up for you. So check back and forth with the answers as you go. All right. Thanks.